So we looked at products, we looked at quotients, we looked at powers, but we have a different situation now. So for example, if I have 3x squared minus 2 to the 10th power, let's decompose this function into inner and outer. What is the inner function here? What is the function that I would evaluate first?
The 3x squared minus 2.
That's it. That's the inner, the 3x squared minus 2. What is the outer? Let's say Josh. What is the outer?
Could it be the 10? Yeah.
10 is not a function.
Yeah.
So what is the function that is the outer?
I'm not sure about that.
X to the 10.
Very good. Of course. So after I evaluate this function, I have a number here like x, and then I have to take this number to the 10th power. Is that clear? Everyone, yes? Derek, Gia, Keelan,
Yes.
Carson, everyone, are you with me, guys? Please. Okay, so this is what we are interested in now. We want to be able to differentiate this function, and I'm not going to raise this to the 10th power. Oh no. So remember when we talked about the power rule, we said if we want to differentiate x to the nth power, what was the answer? Derek, will you help? What is the answer for x to the nth prime?
I'm sorry, could you repeat the question?
Yeah, what do I write here?
Oh, x to the m minus 1. And then, or m times x to the m minus 1.
Okay, the correct answer, which you have, this is correct. But the correct answer should have said, or we should have written this. Why we don't write it? Why this is redundant?
Because it would be a 1.
Exactly. But now we have a function. We don't have x in here. This is a function of x. So when we differentiate a function raised to a power, we have to follow this, including the function prime. So it's the same rule, f to n minus 1, but multiplied by f prime. So n, same thing, it's just that I don't have x, I have f, and so on and so forth. This is basically a combination of f comma g of x, which we know is f of g of x. And from here, let's talk about the chain rule. This is a combination already, the power with the chain rule. So I don't know if you wanted to see this. So now I'm going to differentiate f of a function. And that's exactly the same, but without the power. So f of g of x prime, f of g of x prime. When we evaluate a function like this, we start with the inner, and then we eventually get to the outer. When we differentiate, we do the reverse. We start with the outer, and we get to the inner, and then the innermost and innermost. So this will be f prime, the outer function prime of g of x, times the inner function prime. For example, if I have cosine of sine x and I want to differentiate, sine x is the inner function. I have to evaluate this first and then cosine. If I get here whatever, then I apply cosine to it. But not when I differentiate. When I differentiate, I start from the outer and go to the inner. And remember, it has to be a product. In all these situations when we use the chain rule. Okay, it is a product. So the chain rule combined with the power rule. So I differentiate cosine and I get negative sine of sine x. This is this piece. Now I'm here multiplied by the inner function prime, which is cosine x. So this was an example. And now feel free to, I would like to show one more with the square root. So let's talk about, we already know that f to the nth power prime is n times f to n minus 1 and times f prime. There is no difference with the square root because it's a power. But it's better and easier to remember it as we had it before. 1 divided by 2 times the square root of the function, of course, multiplied by f prime. Where does this come from? From the square root of x prime equals 1 over 2 the square root of x. Okay, so let's work on a problem like this, and then I'll let you choose whatever you want. So I would like to choose, please feel free to choose the next one. So this is the square root of 1 plus 2e to 3x. Okay, y prime, or if you want, dy over dx is what? Anyone would like to start?
So it'll be 1 divided by 2 times the square root of all that. And then it would be 3. I actually don't know how to do 3x to 2.
So when we differentiate a constant times a function, the constant stays in front. When we differentiate e to 3x, we differentiate the function times the inner function prime. Let me give, before I come back and simplify this, let me explain. So when we differentiate e to the x, we know this is very nice, it's e to the x. But if we have e to a function prime, same thing like before, e to that function, but multiplied by the function prime. So when we differentiate e to 3x, of course the constant stays in front. E to a function prime is e to that function times the function prime. In this case, 3 to the x prime is 3. Yes, I will simplify. And the final simplified form will be 3 e to 3x, everything divided by the square root of 1 plus 2 e to 3x. Any questions?
Will we have to rationalize the denominator, or can we just
No.
leave it like that?
No. We normally, it's a very good question. We normally rationalize if we have something like this and we write it as the square root of 2 over 2. But if it's a function like that, no. Unless we are required to for whatever reason. In general, no, we don't bother with that. But it's a very good question. Good. Would you like to choose anything else, or I will? Any questions? Okay, then I will continue. This is a typical type of problem as g of y. No, the notation doesn't mean anything. I'm just saying a rational function like this type. Without the chain rule, I would not be able to differentiate this. So g prime of y. I will square the denominator. Can anyone square the denominator for us?
is it going to be y to the fourth plus?
Can anyone square the denominator for us? You're way ahead of me, which is wonderful, but I want to square the denominator.
Raise it to the second power, or raise it to the 10th?
Very good. Excellent. Good. So now, Mark, I'm here with you. Ready.
I'm not sure I'm doing the thing that you actually wanted me to do. I might have been doing something else by mistake.
That's okay. So let's differentiate the numerator. Can anyone differentiate the numerator, please? Ian, would you like to try y minus 1 to the fourth power prime?
I'm not sure.
Will
the first term be 4y to the third?
4y minus 1 to the third power times the inner function prime. But how much is the inner function prime? What does it equal to?
1.
Perfect. Times the denominator, y squared plus 5y to the fifth power, minus. I copy the numerator. And now, can anyone differentiate the denominator for us?
It's going to be 10.
It-
Correct.
Okay, it's 5 y squared plus 2y raised to the power 4.
Very good. Of course, I ran out of room. So right here, I have to have multiplied by the inner function prime.
Y plus 2.
1.
Y squared plus 2y prime cannot be 1.
2y plus 2.
2y plus 2. Awesome. Do you want me to write this?
Confused.
Go ahead.
I'm confused why you squared the denominator and raised to the 10th power.
So there are two questions in there. Why we square the denominator? Is that part clear?
No, that's why I'm confused.
Okay.
Where I got confused.
So the first function over the second function prime, the rule is y prime times 2 minus 1 times 2 prime divided by 2 squared. That's the rule that I have to use. That's the quotient rule. Is that okay?
Yes.
And the second answer, I think the second question is, when I square or raise an exponential notation to a power, I copy the base and multiply the exponents. If I want to square this, which has power 5, and I square that, I have to multiply the exponents based on the exponential rule.
Perfect.
Is that okay, everyone? Do I need to?
Are we basically doing the chain rule twice then?
Every time I differentiate a function raised to a power, I always have to use the chain rule if it's applicable. Yep.
Okay.
Yep. So do you want me to write this one more time because I ran out of room here? So there is a multiplication here up here.
Please.
Sure. So then I'm going to try to write slightly smaller. So the denominator is y squared plus 2y to the 10th power. We understand all steps at the top, correct?
Yes.
Is this okay?
Yes.
Perfect. So now I need to rearrange it. I'm not going to do anything to this, but what I would like to do is factor out a 2. Maybe not. Okay, let's not complicate that. I have to find I have to find the greatest common factor in the numerator. So as we see, how many terms do we see at the top? Can anyone identify the number of terms we have at the top?
Five.
Terms.
2 terms.
2 terms. Here's one, and here's the other. Good. What do they have in common? Let's say, Sarah, what do you think they have in common?
The y minus 1.
Good. Which power?
To the third.
Excellent. The smallest of the two. Great job. What else?
They have a y squared plus,
Good. Which power?
is that a 4? I can't see on the right. Yep, 4.
Good. So let's open brackets. What is left from the first term?
Is it just 4?
Okay. What else?
Y squared plus 5y.
Y squared plus 5y. Excellent. Now we reach the minus. Good. What is left from the second term?
Y minus 1.
So there is a 5. Indeed, there is a y minus 1. What else?
I have a quick question.
Go ahead, please.
So on the second term, it's a y squared plus 2y instead of 5y. So how can we,
Oh,
no, down, on the term 2,
got it. I got it. I got it.
All right.
Give me 1 second.
All right.
1 second.
so now we can differentiate like y plus 2, otherwise. Yep.
For some reason, I wrote 5. I'm not sure why. Thank you. Well done. Good. And then,
Pause for a sec just to make sure I can get these corrections.
say it again.
Can you just like pause for a sec to make sure we got these corrections?
Yeah, it's not 5y, it's just 2y, of course. I invented a 5y in there. So what is left here? So 5.
Y plus 2.
2y plus 2. Very good. Good. So now in brackets, we have to distribute whatever we need. The 4 in here, multiply these 2 and distribute the -5 and simplify fully. Any questions? Any questions? Everyone with me?
Yeah.
Yes.
Thank you.
Yes.
Okay, so then y minus 1 to the third power. 4 from these will go away, so we have y squared plus 2y to which power?
6.
6, very good. So then we have y squared plus 2y to the 6th power. And then I'm going to distribute. 4 to y squared, 4 to 2y, -5 for now. Y to 2y, so it's 2y squared plus 2y minus 2y and minus 2. These two will go away. Almost there. It's a lot of work on these problems. Y minus 1 to the third. So 4y minus 10y squared will be -6y squared. And this will be plus 8y. And this will be plus 10. Over, we can factor, but that's good enough. So y squared plus 2y to the 6th power. I will recommend factoring out a -2. Y minus 1 to the third. And then we have 3y squared minus 4y minus 5. I'll write it one more time. It's very clear. 2, y minus 1 to the third. You don't have to write it twice. 3y squared minus 4y and minus 5 over y squared plus 2y to the sixth. A lot of steps, obviously, here. Would you like to choose anything else? Okay, we can choose a messy one, something like sine applied to sine, which is applied to sine. This is a pure chain rule. It's not a combo with rational, it's not a combo with a product, it's not a combo with a power.